I think I'm in love. I learned a new way to find prime factorizations, and I can't wait to share it with you. But first, let me remind you how we find prime factorization using a factor tree. Our goal is to take a number and break it down to the prime factors that can be used to build it. So I started by breaking 24 down into 4 times 6. Since 4 isn't prime, we can further break that down into 2 times 2. 2 is a prime number, so I circle it and I know that part of my tree is done. Now 6 isn't prime, we can write that as 2 times 3, and I circle both of those factors because they are prime as well. So we can write 24 as the product of its prime factors. So that's 2 times 2 times 2 times 3. And let's check. 2 times 2 is 4, times 2 is 8, times 3 is 24. And since we have 3 factors of 2, we can simplify this as 2 to the third power times 3. And since we only had one factor of 3, 3 to the first power is just written as 3. So this is called our prime factorization. But like I said, I just learned this new method. We start by writing this number inside of what kind of looks like an upside down division symbol. We need to find one prime number that divides evenly into 24. Since 24 is even, I know it can be divided by 2. 24 divided by 2 is 12, so we write that underneath. Draw the division sign again, and now we're looking for another prime number that goes into 12. Again, 12 is even, so I know I can divide it by 2. 12 divided by 2 is 6. 6 isn't prime, so we keep going. Again, 6 can be divided by 2. 6 divided by 2 is 3. Now, 3 is prime, so this is where we stop. Now take a look at this L. These are all of the prime factors of 24. 2 times 2 times 2 times 3 is 24. And so just like with our factor tree, we can build our prime factorization. Now, you might not be too impressed with this method yet, but wait till you see how this helps us with our greatest common factor and least common multiple. Now, why don't you try to find the prime factorization of 30? Do it with both methods and let me know what you get in the comments.